Without properly rated insulation and circuit protection devices, insulation melting, noxious smoke, and even fire can occur in your electrical system. Circuit protection devices come in two general categories: fuses, which respond to a high current event by permanently blowing an internal conductor, and circuit breakers, which utilize an internal current sensing method to temporarily disconnect an electrical path with the potential to later reconnect that same pathway. Regardless of the category of circuit protection chosen, there are several key parameters that must be understood in order to choose a proper solution. Firstly, we need to ask ourselves what the maximum potential voltage that the circuit protector we need must operate under. For mobile DC systems, these voltages are typically 12, 24, 36, or even 48 volts or more. AC systems are typically 120 or 240 volts. Circuit protectors must be rated by the manufacturer to operate at the maximum voltage range of your system, including the potential for charging voltage, not just the nominal voltage. For example, a 12-volt system could experience charging voltages up to 16 volts, and a 24-volt system could experience charging voltages of up to 32 volts. If a circuit protector is not rated to or for the maximum voltage, the device may fail to protect the circuit by opening up safely, resulting in a failure to prevent the potential damage. The second parameter to understand is the total potential short circuit current that the power source could provide. This can sometimes be challenging to determine. We will cover this in more detail in a separate video, but the table here provides a good starting point for amps interrupting current, or AIC, that many common DC batteries could deliver into a faulty circuit. Circuit protectors must be rated to withstand the potential AIC, otherwise when the device is needed most to protect the circuit, there is a potential that it will catastrophically fail, and a short circuit may remain in place, causing further system damage. For example, if we have a 120 amp circuit breaker with an AIC rating of 500 amps, and then a short circuit event occurs and pulls 1000 amps, this can cause the breaker to be so overloaded that it does not trip and causes an even bigger problem. The remaining system parameters that we will discuss are needed to determine the most common decision that system designers and installers face: the nominal electrical current that the circuit protector is designed to support. This decision requires several system and circuit parameters. While we discuss choosing the right wire in a separate video, the maximum current from the loads connected to the protection and maximum current that the wires connected to the protector can safely support are the first data points. In order to ensure a level of safety factor, it is recommended that the protector be rated to no more than 75 to 85% of the ampacity rating of the wire. Circuit protectors are not exact devices, and while they must hold their maximum rated current, they are not precise instruments and can open anywhere from 110 to 135% of their rated current, with time frames ranging from a few minutes to hours. If the wire is rated for 100 amps, this means a good choice for a protector current rating would be 80 amps. Another parameter that we want to highlight for choosing the proper current rating for a circuit protector is the ambient temperature where the device will be installed versus the type of circuit protector chosen. Because both fuses and circuit breakers have measurable derating and current carrying capability as the ambient temperature rises, care must be taken to understand the maximum expected ambient temp and to derate the circuit protector's capability. Derating will factor in the ambient temperature and reduce the expected maximum current that the protector will carry without prematurely opening under normal operating conditions. Finally, it is important to circle back and check that the derated carrying current of the protector will support the expected maximum current from the loads on the circuit. In this video, we provided a high-level summary of how to specify a circuit protector in a mobile application, so it is by no means exhaustive. We will offer more detail in other videos, but hope this will serve to raise awareness of many overlooked aspects when selecting a circuit protector for your electrical system. Thank you all for watching this episode of Circuitry 101, and until next time, bye for now.